Hello students, today we are going to start with the class 2 which is representing the difference between network security and application security, and this content is taken from Web Application Security, a beginner's guide textbook, so that I have represented over here. So, we are going to see what is the major difference between network security and application security. Before seeing that, we will see some introduction about it, right? So, in this global information technology industry, it faces different significant issues despite of massive annual spending. Several data breaches continue to occur because of security investment priorities, right? So that is what why we need the security in different areas because of this breachings, right? So survey suggests that 70% of attacks originate through web application. So that only web application security is very much mandatory compared to other normal securities, right? And then many organizations devote less funding to application security compared to traditional network security like firewalls, right? So firewalls are providing only to the network. So now first we will see the difference between application security and network security, right? So network is nothing but the communication medium which is available between the sender and receiver. That is what the network, right? So the communication medium, if it is affected, then it is coming under network security. If the application which is running in the server, if that particular application is affected, so we know that how the application is services are retrieved using the endpoints, that is known as port and protocols. So if that particular application is affected, then that is the compromisation of application security. So this imbalance is problematic because of network firewalls are only providing network security, and most of this securities are ineffective for web application attacks, right? So here there are some examples where we are representing the attack for the application security. So if there is an attack in port 80 for web traffic, that will also represents the open for user access, right? So high profile attacks such as SQL injection attacks and then cross-site scripting. So this and all we will see in the forthcoming slides, right? So we will see what is SQL injection attack, and the next lectures and all we will see what is cross-site scripting attacks and all, right? So these are significant attacks which are implemented in the application level, and it will weak the application logic, right? So if the application logic is also weak, then there is a possibility of SQL injection and cross-site scripting attack. Okay, so now let's see move on to how to represent that cross-site scripting. Just a second. So first we will start with how SQL injection attacks are represented. So these are class of security vulnerabilities where an attacker manipulates SQL queries. So we know that how we are representing an URL. URL is represented as first port, first protocol. So we are using HTTP or HTTPS protocol, followed by domain name, and followed by port number, but the port number is optional. You can either give the port number or you can leave it, and followed by the path information where the query string is also after path information the query string is also passed, right? So this is how we are representing an URL. In this query string, if you are representing this malicious input to the web server, automatically if the web server should not provide the content, right? So if the application logic is weaker, if the attacker is trying to get the data, automatically using this query string parameters, if the data is retrieved without authorization or authentication, then that is known as SQL attacks, right? So that is what represented over here. So now let's see how the SQL injection works. right? So as I said before, whatever content represented in the black color font is from the textbook, and the purple font represents to give a detailed content about a particular topic, right? So now we will see what is SQL injection and how it works. Many applications build SQL queries by concatenating user input directly into that query, right? So if that input isn't properly handled, an attacker can change the query's logic. So that is what, if the query's logic is changed, and if it is generating the result as true, automatically the web server will provide the corresponding content to the attacker, right? So this is an example how a particular vulnerable example for SQL injection, right? So we are just giving the username is equal to admin and password is equal to password, right? Or if you are not giving the exact username and password, if you are giving only this condition. So what this condition specifies, 1 equal to 1, right? So, so if 1 equal to 1, yes, always 1 will be equal to 1 and it will return true for that case. So if it is 1 equal to 1, whatever statement it is representing here, and then this or statement, right? So since any one condition can be true, that is what or statement. So whatever statement is represented before or this condition, if this is true, automatically it will retrieve the content what we have represented in the select statement, right? So some of the examples what I have executed, that examples I have given here as resulting query. If you see here, select asterisk from student where username equal to, just I'm representing with that or statement with a blank single quotes and then or. So always if this will be true, so it will retrieve all the students, right? So I will show the demo also how it is retrieving all the students without so we are not giving any username, but this condition is true always, so it is retrieving all the student. Similarly, if you are giving a condition where password is also whatever pass, we are not giving any password, we are just giving single quotes two times, and then we are checking with the condition 1 equal to 1. So here also 1 equal to 1 is true, here also 1 is equal to 1 true. So it will also display all the students, right? So that is what, and if you execute this particular statement, if your database is not sanitized, or if it is not providing any, if it is not providing any security, then automatically for this query also it will retrieve the content, right? So but for my database also I am using DB browser for showing the example to you, so I will show that for but this DB browser, what it is doing, it is not showing any error for this query, but this query is vulnerable when it is executed in the web server, right? So this condition is always true, potentially granting access to the users. Okay, now let's start with what are the common types of SQL injection. So first type is classic in-band SQLi, right? So the type specifies the attacker gets results directly via the application. Example, login bypass, right? So without so that is what I have already represented in the first class when I'm taking the first class. So without giving the username and password, that will be bypassed and directly they can able to access the application. And now you can think what is application security plays here, right? So it is not going to be identified by the network security examples like firewalls. So next is blind SQLi. So no direct output. Attacker infers data by observing application behavior, right? So it won't have any output for that query, but it will infer the data based on the behavior of the application, right? Either it is true or false, or if the responses are fast or it is delayed, like that it will identify. Next is represented as error-based SQLi. So database error message reveal information about the schema or query, right? So if you, this whenever you are trying a wrong query, automatically it will specify what should be the schema it has to use to represent that query. So next is union based SQLi. It uses union select to combine malicious queries with legitimate ones to extra data, right? So this is how we are representing union based SQLi. So the union is used along with the query statement with any other query statement which is not permitted, right? So automatically it will align with the existing query statement to get a vulnerable to get the data which is vulnerable for the web server. So next is out of band SQLi. So the data is exfiltrate via external channel. So that is the data is filtrated via external channel, that is using domain name system or HTTP request. Using this type of SQL injection attack will occur. So now we will see the impact of SQL injection. So the impact of SQL injection represents unauthorized data access. So user data or password. Without that, we are gaining the access, and data modification or deletion, authentication bypass. Again, these two are dependent, and full database compromise because of any one type of SQL injection. In some cases, remote code execution is also possible. So how to prevent this SQL injection? So these are the techniques. Either you have to use quality ORM frameworks, or you have to use the parameterized queries to avoid this, right? So we will see one by one. So first, use prepared statements, which is represented as parameterized queries. So select asterisk from user where username equal to you have to specify the username exactly without any special characters, and password is equal to the exact password. And then use ORM frameworks. So the ORM frameworks provides Hibernate, Sequelize, and then Entity framework, and then validate and sanitize input. Right. So front end validation, back end validation, both are available in your web application. So you have to, before touching the database, the input should be validated in the front end, and it should be sanitized, specifying it should contain only 8 characters and no special characters should be available. Like that, you have to sanitize the input, which checks the type as well as the length limits. So next is use least privilege database accounts. So that means that always least privilege database permission will be provided, and once the token for authorized to gain resource for other important tables or database available in the web server, then the token should be exchanged. First, whatever the user may be, the least privileged database account will be given. So next is disable detailed SQL error messages in production, right? So with the error message, the hacker will identify what should be the schema of that query. So we have to avoid providing detailed SQL error messages, and then regulating security tests. So this security test static one, and this is dynamic one, and this is the penetration test, right? So we will see the difference between the static security test and then dynamic security test, and then penetration testing. Penetration testing, it will go like an peeling off onion from the outer layer to the inner core of the application. It will keep on testing, right? So now we will see the difference between static testing and dynamic testing, right? So first, if you consider the feature testing type, here it is static and here it is dynamic. And the code of access, here it requires code of access, and the code of access is not required. Runtime needed, static is not needed in the runtime, but because it is a pre one, before execution itself, this static testing will be evaluated. Excuse me. And then next is dynamic testing. Here the runtime needed is mandatory because it is of post, right? So next is finding vulnerabilities. It is potential, whatever potential vulnerabilities are available, that will be identified in the pre-stage, and then the actual vulnerability which is caused during the execution, that is during runtime, that will be identified in this dynamic. And then false positive is higher. So you know what is false positive. False positive means measuring a particular data as correct one, but it is a wrong one, right? So that is what false positive. It will identify this is a threat data, but it is a normal authenticated data, right? So that is known as a false positive. That rate of false positive is higher in the static and lower in this dynamic. So best stage, here it is yearly. That is what I told. It is a pre-processed one, yearly SDLC, and here it is late SDLC, right? So like this we are representing the stage. So next we will move on to the database. So let me present it with the data. Okay, now let me show you the database, how it is representing in this DB browser. So this is what the database, what I have created. If you see here within the database, I have, so it is new db.db. This is the database name, and student is the table name which I have represented over this database. So just I'm clicking on student. So if you see what are the fields that are available in student is name, roll number, username and password. Just for an example, for executing that SQL injection query, so I'm showing this example, right? So it consists of four fields: name, roll number, username and password, and I'm going to execute the query using this table information. So let us see how it works. So execute SQL. So let me copy paste whatever the queries we have seen in the content of this class. So let me choose that and paste it here. So just I'm deleting this query and then pasting it. So if you see here, always 1 is equal to 1 will be true. So this is one type of SQL injection, and I'm going to execute this query, right? So it is displaying all the data, right? So even though I have not given the username properly, this particular condition is satisfying for me because of this or statement. Or statement joins these two state, either these two condition is true, it will generate the output, right? Actually it should not do that when while you are working in an application with the web server, right? So this is how it is executing and retrieving all the data from the data table, right? So this is one type of SQL injection where 1 equal to 1 is the statement what which will result always in true. And another statement I will execute and show it to you, where it will execute, but it will not generate any error, but as well as it will not show the output also, right? So that type of representation is given. So if you see the output over here, it will not show any output, but it will not show error also. That is also vulnerable to the web application. So let me paste it here. So here the table name is student. So just I am changing it to student and then executing it. So if you see here, it is not displaying any content from the table, as well as it is also not throwing any error. It is finished without errors, right? So this is also vulnerable one, but because it is touching the application without the permission, right? So that is known as application security. So that is what we have seen with an example of SQL injection, right? So here DB browser for SQLite, I have used this particular database connecting to the database new DB. Within that new DB, table student is described. Okay, now we will move on to the content once again, right? So far what we have discussed here is about how to execute simple queries which is causing SQL injection, and then what is SQL injection, what are their types, and how to avoid SQL injection, what are the procedures, and the difference between a regular security testing, static versus dynamic is also detected, right? So best stage here, it is early SDLC, late SDLC, that means it is pre and this is post. So next is example of secure code. So here also one more example they have represented here that will represents how to execute uh, SQL injection using this module, right? So cursor dot execute, select asterisk from users. The user is a table name where username is equal to percentage yes and the password is person. So what we have understand so far, any special characters or any numerical values which is not authenticated should be sanitized and removed in the input validation itself, right? So username and password. So key takeaway from this is SQL injection is one of the oldest and most dangerous web vulnerabilities, but it is also entirely preventable with modern development practices, especially parameterized queries. Right? Okay. Okay, next we will start with network security versus application security. In the textbook, this network security and application security is described with an example with a story of wizard and the magic fruit trees, right? So let me tell that story to you to understand what is network security and what is application security. So wizard and the magic fruit trees we are going to discuss. So consider uh, there is a garden where there are so many number of trees, plants are available, which consist of different types of fruits and vegetables, right? So what the wizard tries to do, this person wizard is a good person and he wants all the people who are living in the village to be benefited with the fruits and vegetables whatever is available in the garden. So what he done, he have developed so many number of trees as well as plants to serve the villagers. So everything is going fine until the wizard started monitoring the garden. One day he started monitoring the garden. At that time, one person has started carving his name in the lemon pear tree, right? So in the lemon pear tree, so the lemon pear tree is nothing but it is not a lemon tree, it is a pear tree which looks like yellow color, right? So hence it is named as lemon pear tree. So in that lemon pear tree, one particular boy started to carve his initial in that tree, and he wants to throw him out. So he went fast towards him. While he going through that way, the wizard started seeing another two people from the villages started digging up two trees to take the trees to their place, right? So and then he got frustrated again. Before reaching that particular tree, he has come across two more wizards. Those are very dangerous, that means bad wizards. They are trying to burn the garden itself, right? So by seeing all these things, wizard got very angry, and he has created a molten lava molten lava around the garden, right? So he has digged up surrounded by the garden. So if you think this is the garden where there are trees are available and garden is so with he has digged the entire surrounding of the garden, and molten lava is poured over here to safeguard it from the villagers, right? So now the disadvantages is, so far the villagers used to get the fruits and vegetables easily before this molten lava is poured over here. But now it is not easy for the villagers to access the garden, because there is a molten lava between the garden and then the villages, right? So now the wizard is once again, he become very sad because it is not accessed. What he tried to do, he started he bought a giant to safeguard this garden, right? So a giant is bought to safeguard this garden, and so now you know the network is broken, right? So the network between the villagers and then the garden is broken because of this molten lava, right? So a giant is brought to this garden. So what the wizard ordered the giant, whatever the villagers is asking, that should be provided to the villagers immediately, right? So the giant started to what whoever is asking for apples or orange or any vegetables, he started to throw that to that particular villagers, and once again the villagers become happy, right? So days goes on like this, so many number of days. Now the wizard is very happy because the villagers are happily utilizing the fruits and vegetables. One smart guy or one attacker, we can say him as an attacker, right? So one smart young guy came to the giant, and it is asking for the scroll, which is nothing but the magic stick which is used by the wizard to create this garden, right? So that smart young guy asked for the scroll to throw. So the giant, what is the order is given to the giant? Whatever the villagers are asking, that should be thrown, right? So automatically giant thinks of it, and then okay, whatever is asked by the villager, we have to do it. So automatically he went to the top and throw the scroll to that smart guy, right? And he went away with that scroll. So the story specifies that whatever we are doing the configuration in the application layer, that should not be any weak logics that can penetrate through the attackers, right? So that is what represented here as application logic. So it exploits flaws in the application logic and compromising the data, right? So that is what given in this story, and that is the difference between network security and application security. And based on so with the story, they have in your textbook they have explained this application security and network security. So now we will see with an exam with a detailed instruction about different aspects of network security and application security, right? So the first aspect is layer. So network security is working on network and transport layer. So in OSI model, you know where network and transport layer comes in: physical, data link, network and transport. These two layers are working for this network security. Application logic is working in the application layer. So after transport, session, presentation and application, and this is for application security, right? So I think you understand where the layers it is working. And visibility, it is a traffic and connection, and it is a code and behavior for application security. And the primary goal is block unauthorized access, and it prevent exploitation. Example attack: DDoS attack. and it is an SQL injection attack. And DDoS, here DOS means distributed denial of service is DOS, distributed denial of service is DDoS, and SQL injection in application security. The fixed location for network devices, here it is application code, and ownership it is network slash SOC teams. Source of code, and then here developers app security teams, right? So these are the developers and app security teams. Next comes thinking like a defender topic. So that's all about difference between network and application security. Next is thinking like a defender. So vulnerability typically stem from simple application logic flaws. Developers should cultivate a mindset focused on defense and master in general security principle. Right. So developers should think like a attacker also. That is what they are trying to specify here. Rather than attempting the difficult task of anticipating every specific future attack technique. Focusing on general principle offers better protection because it helps prevent entire classes of vulnerabilities such as SQL injection, cross-site scripting, and buffer overflows, regardless of how the specific methods of attack evolve over time. Furthermore, smaller companies should not assume they are safe as attackers increasingly target the vast array of web applications belonging to smaller organizations, right? So that's all about thinking like a defender. So we have to think like a defender of, as well as how the attacker will also think, that should be also uh, consider in the developer's case. Next, we will see what are the 10 top list of open web application security project. OWASP is nothing but Open Web Application Security Project. This is very much important. So you have to concentrate on all the 10 topics under this Open Web Application Security Project. So why we have represented this as top 10 list? It is a most critical web application security risk, ranking the most common and demanding vulnerabilities to guide remediation efforts. So key items on this list include, first one is injection. So we know what is SQL injection, and I have given an example for how an SQL injection will be executed. So allowing attackers to execute their own command on the server, right? So that is known as SQL injection, and that command is nothing but the query that is passed in the URL. Next is cross-site scripting. So this is the most pervasive web application vulnerability involving injection scripts like JavaScript or HTML into the vulnerable pages, right? So we know there are two types of scripts. One is client-side script, another one is server-side script, right? Injecting the vulnerable page, either a JavaScript or HTML page into the client side or server side is known as cross-site scripting. So the script itself will be compromised. That will lead to theft of token, session token, and creating malicious self-replicating worms, right? So these are the effects of this cross-site scripting. So next is broken authentication and session management. These flaws arise from insecure handling of session identification tokens, right? So sessions should be maintained properly. If there is a broken session, the hacker will take over from that broken session into the web server, right? And managing the stateless HTTP protocol, potentially leading to predictable identifiers or exposed tokens in the URL, right? So token should not be exposed directly in the URL. It should be encrypted, right? As well as we have to use HTTPS protocol instead of HTTP protocol, which is stateless. And then next is insecure direct object reference. So we will have different object reference by representing the buttons and links that should be secure. If it is insecure, that will also leads to pointing to a credential data which is available in the database. So application reveal internal naming convention like file names or database keys via URLs, enabling attackers to gain unauthorized access to resource simply by manipulating input parameters, right? So that is what the parameters which are referenced should not be manipulated. So if it is manipulated, then that particular reference are known as insecure direct object references. Next is cross-site request forgery. So cross-site scripting is inserting HTML or JavaScript code into the client side or server side. Cross-site request forgery is an attacker's trick a victim's browser into sending an authenticated request to a vulnerable site, right? So the victim is nothing but the client side. So he will take over the control of client machine, and then it will start sending authenticated requests to a vulnerable site by exploiting the fact that browser automatically includes the victim session cookies, and it will start monitoring the victims whatever the content they are browsing. Next is security misconfiguration. Vulnerabilities resulting from improper setup such as inadvertently deploying development or debugging configuration to a production environment, right? So that is what security misconfiguration. This leads to weaker application logic. And next is insecure cryptographic storage. Sensitive information such as password should never be stored in plain text. Best practice dictates storing a one-way cryptographic hash, right? Because why it is represented as one way? If you reverse it, you cannot get the plain text, right? So that is why it is represented as one way hashing. If you reverse it, you will not get the plain text. So often combined with a random salt value, that is nothing but a random value generation. So next is insufficient transport layer protection. This involves failing to use HTTPS. That means it is using HTTP. That means automatically it is not including secure socket layer, which is SSL and TLS, right? Transport layer security. If it is HTTP protocol, it will not use these two. If it is HTTPS, since it is secure, it is using secure socket layer and transport layer security that will consistently across the entire application. It will this layer will be available, which expose authentication tokens if authenticated pages are served over unencrypted HTTP, right? So that's all about top 10 list of OWASP, which is Open Web Application Security Project. So next is secure futures. So just a summarization of this content. So it is critical to focus development effort on writing secure futures, applying security expertise to routine development tasks like handling strings or querying databases rather than focusing solely on implementing security features traditionally associated with IT like firewalls, antivirus, or SSL. So the majority of the items listed on OWASP top 10 result directly from improperly coding normal everyday application functions, right? So with this, we are completing unit 1 of web application security. In the next class, we will start with unit 2. Thank you.